University Electrical and Electronics Engineering Department. I'm Gözde Körpe. I'm Edanur Potuk.
I'm Baturay Aydemir.
And I'm Yağız Avşar. Welcome to our graduation project presentation video.
The Driving Assistance System.
Initially, users have the flexibility to enable or disable features using our interface, as you can see in the images. In our project, we developed a lane detection system using OpenCV and Python. First, we used the can-age detection method to identify the edges in the image. Then, using half transformation, we transformed these edges into correct segments. As you can see in the video, once the lanes are detected, we integrated a warning system if the vehicle leaves its lane or does not continue in its lane. However, the system may not work correctly in all conditions, especially on poorly maintained roads or in harsh weather conditions. Lack of clear lane markings negatively affects our system performance. The integrated lane keeping warning system provides instant feedback to the drivers, increasing safety and improving the driving experience.
For hands-on wheel and eye tiredness detection, we use MediaPipe, which is an open-source framework for building pipelines to perform computer vision. Hands-on wheel detection algorithm first detects the steering wheel with the help of its ellipse-like shape. After detecting it, it only checks for its position every 10 minutes, assuming the camera's and wheel's position stays the same. Then it detects the hand landmarks, and if the fingerprints or palms are not on the area of the steering wheel for 3 seconds, it gives an audio warning. The eye tiredness recognition system finds the edge of the eye and calculates the eye aspect ratio, and if it's below the threshold for 3 seconds, it gives an audio warning. This system works with glasses too. However, when the driver is wearing a sunglasses, it detects that and gives a warning that the eye tiredness recognition algorithm won't work. It's one of the limitations of our system. We are getting the speed data from vehicle's ODB port. The code filters the messages that we get according to its ID, so we only get the speed messages. After getting the raw canvas data, which is in hex, it does the necessary decodings to get the speed in decimal. It should be noted that to do such a calculations, we need to know some car-specific values like signal IDs and resolutions. Our system is tested on Peugeot and Citroën.
Aim of the car and pedestrian detection model is detecting cars and pedestrians and warn the driver if an accident is about to happen. This problem requires a detection model and a crash algorithm for warning. For detection model, we use the model DetectNet provided by NVIDIA. DetectNet is an SSD MobileNet version 2 based model specifically designed for Jetson Nano devices. We also developed a car crash algorithm on Python. We use the bounding boxes of the detected objects as an input and compare them with the so-called possible crash area. As can be seen in the video, this area is defined as a trapezoid in front of the car. The height of the trapezoid is changing according to speed of the car. The speed is provided by the canvas interface that we presented earlier. We also keep the records of the last 2 hours in case of any accident happens.
The traffic light and traffic sign detection system is implemented in the framework of Darknet for YOLO system. This system is fed with hundreds and thousands of images from the roads of Turkey and Europe. By detecting the speed signs, our system can give warnings to the driver if the current speed of the car is bigger than the speed sign detected. As you can see, there are false detections. These are corrected afterwards with the warning code by using a buffer and checking the last several detections and confidence values. Despite our best efforts, the implementation of this solution into our Jetson Nano was not possible because of the limited resources the card has. Regardless, this system is designed to work in parallel with all the other subsystems and work with the speed data from our CAN bus subsystem.